Here's a video that will help you understand how to find the percent of data above a particular score and the notation that goes with it. Gestation period. The length of human pregnancies from conception to birth varies according to a distribution that is approximately normal, with mean 266 days and standard deviation 16 days. First question, A. What percent of pregnancies last more than 245 days? What you first want to do is define the variable. So X is the length of pregnancy. And so now you want to use or write normal notation describing that X is normally distributed, or X is approximately normally distributed with a mean of 266 and a standard deviation of 16. Part 2 to your answer is doing the math. Part 1 was to find the variable, Part 2, do the math. So we want to find the probability that X is greater than 245 in approximately normal distribution. So what you want to do is convert this into a standardized value. So we're looking for the probability that Z is greater than 245 minus 266 divided by 16, which is equal to probability of Z greater than a negative 1 and 31/100ths, which gives us the area above a negative 1.31. But if we're going to use table A to find this value, we are looking at 1 minus the probability then of Z being less than or equal to a negative 1.31, which is equal to 1 minus, here's where you need to go to table A and look up this particular value, and that comes out to be a standardized score of 0.0951. 1 minus that, 0.9049. Step 3, answer the question and make a graph. So approximately (90 49/100ths% of pregnancies are more than 245 days. What this looks like in a graph there's our horizontal axis. I'm going to label that X. The mean is 266. Now, a shortcut to making your normal bell curve is to count by intervals that represent 1 standard deviation. So if that's 266 with a standard deviation of 16, that means this is going to be 282. Let me change colors. 282 plus 16 more, 298, and 314. This represents the number of days. Go in the other direction, this is 250, that's one standard deviation below, and 234 would be two standard deviations below. 218 would then be 300 standard deviations below. Make our approximately normal distribution, and then 245 would be right about there, and we shade everything above. Now there is an alternate way of labeling your axis. You could have had on your axis standard deviations 0, 1, 2, 3, and then plot a negative 1.3. 0.31, and then shade everything to your right. So you're repeating everything up here, but just with a different label across the horizontal axis. And I just noticed that up here I had misspelled pregnancies, and I'm just going to fix that really quick. Again, we're dealing with the gestation period with a approximately normal distribution, mean of 266 and standard deviation of 16. Find the interval for the middle 68% of the data. There are a couple of ways to do this. Option 1 allows us to use the empirical rule. So since I've already defined x in the previous problem, I do not have to go through the definition of x, and noting that x is approximately normally distributed with a mean of 266 and a standard deviation of 16. But according to the empirical rule, we're looking for the probability of a z-score between one standard deviation below and one standard deviation above, which is equal to the probability of x, the number of days of pregnancy, being between 250 and 282. Now, therefore, the number of days of pregnancy has to be greater than 250 days and less than 282 days to fall within that middle 68%. Three dots stands for therefore. Option 2, and option 2 works better with different percentiles than the 68, or works better with middle percentages other than 68. So for option 2, what you could say is go to table A, and your middle 68% actually corresponds to a z-score that's between a negative 0.99 and a positive 0.99, which is equivalent to x being greater than or less than 250.16. Let me write that a little bit better. hate to write inequalities from left to right, but due to space, go 250.16, x 281.84, and those values I got by using x minus 266 divided by the standard deviation of 16 equals a z-square of a negative 0.99, and x minus 266 divided by 16 is a positive 0.99. Solve for x, and you get those two values. Therefore, the number of days for the middle 68% is between 250.16 and 281.84. You do need to make a sketch for this. 266. Let me redo that so we can try to get something that looks a little bit more realistic. I'm putting the labels on. This is approximately 282, 298, 314, 250, 234, and 218. That line should actually be just a little bit on the outside. There we go. That one's already a little bit on the outside. So shade everything in between. So let's do it like we did before. Define x. X is the length of pregnancy in days. We then also need to define x as an approximately normal approximately normal distribution with a mean of 266, standard deviation of 16. We are looking for the probability. So now let's do the math. Let's find the probability, wrong color, the probability that x is between 250 and 280 days. Well, that's equal to the probability, and please use this type of notation, 250 minus 266, or use this type of notation when you're doing the work, divided by 16. So z's got to be greater than that and less than 280 minus 266 divided by 16, which is equal to the probability that z is greater than a negative 1, less than 0.875 or 875 thousandths, which is equal to, since we're looking for an interval, that's equal to the probability of z being less than 875 thousandths minus the probability of z being less than or equal to a -1, which is equal to 809 thousandths minus, so 809 thousandths minus a negative 0.1587 or 6,503 10,000ths, better known as 65 3/100%. Therefore, 65 3/100% of pregnancies last between 240 and 280 days. You also have to make a graph for this. 266, 282, 298, 314, 250, 234, 218, excuse me, let me go back a step. I said 240 right there, I meant 250. $250 up to about 280. And then shade your distribution.